All right, we're hitting chapter 3. Chapter 3 is going to be far shorter because remember I said I've been front loading the stuff with, you know, things we would cover again later. Well, what are we going to be doing? We're going to be doing like if statements and loops and stuff like that, which is stuff we've already covered. And we're going to cover it again to burn it into your brain, but we're not going to have to talk about it as much as if you hadn't seen the concepts before. Alrighty. In this chapter, you're going to learn about the disadvantages of unstructured spaghetti code. Well, we don't really have much of a way to demonstrate that. The three basic structures, sequence, selection, and loop. I would consider functions, modules, a fourth basic structure. But they only call those, they call those the three. You know, Prof says modules too. Using a priming input, the need for structure, recognizing structure, structuring and modularizing unstructured logic. Well, some of these I consider more important than the others because some of these you just learn from experience. All right, so what is spaghetti code? Don't type what I'm about to type because this is just pure demonstration of something that's not Python, it's not anything. All right, say you had some code like this. 10 input x. 20 if x is equal to 0, go to 40. 30. Print x. 35. X equals x minus 1. 36. Go to 20. 40. Print done. 50. Go to line 140. And then later on, 160s, 90s says go to 60. And so on, right? This is what the basic programming language looked like in the 70s. Use go-to statements. It's also what, if you were doing assembly programming, would kind of look like. The idea is that it jumps around. In assembler, it's called a jump statement, a JMP, rather than a go-to statement. So we input x, and we typed in a 12. Is x equal to 0? No, it's not. So we skip that statement, right? We don't go to anywhere. So we print out x, we subtract 1 from x, and then we go to 20. It flips back up here. It checks again, right? It was 12. Now it's 11. 11 is still not equal to 0. Print it, subtract 1 from it, go to 20. Well, 10 is not equal to 0. Keep doing that until x finally does become 0. If x is equal to 0, it jumps to 40. Prints done. And then it goes to 140 for some reason. And then line number 140's got a whole bunch of stuff. And then it hits line number 190 and it jumps back up to here. Right, you can have go-to strewn throughout the code. Right, and they'd be just jumping all over the place. Now that was poorly structured code, but you could do it. That's what's called spaghetti programming. Because if you drew an imaginary line from that one to that one, and from that one to that one, and that one to that one, and that one to the right, you know, kind of spaghetti. Very unstructured. Go-to statements work in the languages that support them. Python doesn't even support them because Python has far cooler things. Python has, you know, if statements. Well, I guess that's an if statement, right? But it's got if, elif, else. It's got while loops. It's got for loops. Those are really all we need in order to construct our program, along with function calls, along with module calls. Now I'm going to actually crank up, you know, Python and type in a few notes. But that was an example of a while loop or a for loop written in a language that only supported if statements and go-tos. Are we on K? H, I, J? I think we're on K.
Yeah, we're on K.
All right, why are they called control structures? Because they control the flow of the program. Otherwise, programs just go top to bottom, right? Input X.
March 7th.
Y equals X times 2. Yeah, you're right, March 7th. You know, print Y. Input Z. Z is equal to Z times 3. Print Z, that kind of thing, right? Just top to bottom. That's called sequential flow. So we have several different types of flow control structures. And I'm going to go back and check the PowerPoint to make sure I mirror their text completely. They just called it basic structures. Okay, so you could call them logic structures, basic structures, or flow control structures. Not basis, basic. I'm fond of this term, flow control, because it's controlling the flow of the program. I think I'd rather say logical. Anyways, the book calls them basic, not constructors, structures. Sorry, constructor is a C in a Java term. Basic structures, flow control structures. Book calls them structures or basic structures. I will oscillate between flow control or basic. So they're sequential. That's just top down, right? Do things top down. Thing 1, thing 2, thing 3, right? Start, blop, 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 stop. And I'm sorry, you said something? Yeah, sorry, I scrolled it all off. I sure do love my tab key. I'm going to just highlight all that stuff and tab it, I guess. There we go. Not a lot to say about sequential, although there's a slide about it. It performs actions and tasks in order with no branching or skipping any task. Guess that's worth saying. No branching or skipping any task. No looping, right? Just top down. Then there's the selection structure, the decision structure. If. So. Also known as the decision structure. And that's just if. Or if else. Or if elif else. The book will call it if else if else. But basically that's what we got. If and if else and if elif else. Elif is just a fancy way, it's Python's way of saying else if, which is what other languages do. And that's so-called asks a question, taking one of two actions based on testing a condition. We could word that fancy, and we could say conditionally executes code. In other words, executes code based on a decision. There's two types of selections. Well, there's more. This is considered a third, but we're going to talk about the two. There's single alternative. which is something or nothing. That's just a simple if statement. If age less than 17, print, don't vote, right? We're not doing anything else. We're just checking to see if age is less than 17, and if it is less than 17, we're saying don't vote. That's a single alternative. So that's just an if, a lone if. And then there's dual alternative, which is something or something else. And that's an if-else. And elifs are just chained versions of dual alternative statements, right? If name equals A, print Alice. Elif name equals B, print Bob. Elif name equals C, print Carol, right? More than dual alternative, but it's really chaining multiple dual alternatives together. And then there's loop structures, which repeat actions while a condition remains true. So it repeats code, repeats a body of code, while a condition remains true. The difference between that and a selection structure is an if does some code and then it keeps going, right? But a while will do some code and then it'll come back up and check it again, right? X is still less than 10, so do it again. X is still less than 10, do it again, right? Keep repeating. That's what a loop structure is. It keeps repeating a body of code. We have two looping keywords. We have while and for. And I'll iterate one more time that you don't have to type in my notes line by line if you don't learn by doing that. I've had some, I mean, we're pretty late into the semester and I'm sure you've already made that decision. Some people would rather watch the lecture without having to, right? I think it's always useful to get the code up and running now. And it helps some people burn it in like this. Sequential. Boom, boom, boom. Selection structure. If decision, do something. If there's no else, it just falls through, right? If there was no else, we just draw a straight line down. There wouldn't be anything there. And then they hook back up. When we were drawing it, we hooked it back up in a circle just to make it easy to draw. So this is a single selection structure if I cover up this side. If it's true, do something. Otherwise, don't do nothing. But if there's an else, if it's a dual alternative structure, if it's true, do that. If it's not true, do that. Now, everybody wants an else block on here. There's no else block on here. It's implied by going either that way or that way. If you really want to see the word else, replace the word no with else.
So the circle with the X in it, or
the circle? Okay.
The little circle that you use.
I didn't use the circle with an X in it ever, but let's go look at it. I mean, we could go back in time and find one of my if statements. Well, these are all looking complicated. Here's one.
See down there?
There's a circle there. Doesn't have an X in it.
Over in the flow chart, over to your left.
That way?
Yeah. See the circle with the X in it?
Here?
Yeah.
I don't use those.
See, that's or is the plus. There.
Sure, but I don't use those.
I'm just saying.
Yeah.
Can you use those and to say else?
No. You asked if you could, and I said sure, but it's not part of regular flow charting. If it helps you understand it, it's okay. Just understand it's not part of regular flow charting. That makes sense? The only thing that I would recommend doing if you don't want to customize flow charting, and I won't count you off of that because you already asked me, is stick the word else there.
Yeah.
That's cool. And I think what you did is you dragged over something like that and
Yeah.
put the word else. I understood that that's what you were doing, but that's not it's not part of the standard. So do all alternative ifs contain two alternatives. If something is true, do one thing, else do another. The body that it's executing could either just be one line of code or it could be a million lines of code, right? As long as it's all indented under the if. As soon as it hits an unindented statement, that block is ended. Now, clearly this is not Python, right? We need colons and then there's no then keyword, you know. But it's pseudocode. Single alternative ifs. If the employee belongs to the dental plan, then deduct $40 from their pay. An else clause is not required. Now, I had an editor at one time for an operating system called OS2 that did something really annoying. If you did this, if, and you hit space, it'd go ahead and fill in all this, including the word else, right? And so then if you decide to do that, right, dental is equal to yes, and then you did pay, you know, minus equals 40, right? And then you had this else down here, and you'd have to delete it, or you could just leave it there showing that nothing happens, right? Well, I'm thankful that I haven't run into an editor in a long time that pads out an if, a single keyword if with that much code as soon as you type it. The null case is a situation where nothing is done. It would be like doing this. This would not even be valid Python. I'm not going to show you. It would give you a I'm not going to type it into my code because it would give you a syntax error. But it'd be like doing something like this. If, you know, condition, and then do something else, and then later on we do something else, like we print X or something, right? You can't make an else with nothing after it. The book says that that's a null condition. We're not going to use that. We're going to just delete those options. We understand. I think calling it a null condition and pretending that, you know, I think that makes it more confusing. You won't see any examples in the textbook of code that say that they have an actual null condition. They just threw that term in. So the null case is a situation where nothing is done, right? If that was true, then we deducted it, but the null case is it wasn't true, and so we didn't deduct anything. That's a single alternative, right? There's no else in it. If you did what I suggested and put the word else there, then it's wrong, just like my example here was wrong. Right? Because if you don't have anything there, then it's going to be a syntax error. So if you put the word else here, that's going to be syntax error. Well, I guess flowcharts don't have syntax errors. If you want an else, you better have a block under there. And I just get used to saying yes and no and not putting else anywhere. Like I said, our brains want to see an else shape, but it's not part of the programming. It's not part of the flowcharting standard. It's implied. So a loop structure repeats a series of actions while a condition remains true. We're going to count from 1 to 10, while x is less than or equal to 10. Then there's a loop body inside that. That's called repetition or iteration. Each iteration. There are while loops, and then in some languages there are do loops. Ours doesn't have that. I'm not going to be talking about do loops very much. Maybe just enough to keep it in mind if you do the MindTap exam. So the condition is tested first, and then it goes in. And we may, since we actually haven't thrown any code in, we may as well put that into our code. So x equals 1, and then we're going to make a while loop with a body. While x is less than or equal to 10. That's the condition. Let's put that as a comment. Now here's our loop body. Print, parentheses x, and then x plus equals 1. Add 1 to x. So this is part of our loop body, and so is the next statement. This is a special part of the loop body called the update of the loop control variable. The book was also going to call this the loop header. We've got to have more than one term for everything. So maybe I'll go back and I'll insert the word loop header in front of condition. Loop header equals the condition. This is a special part of the loop body called update. They may call it something slightly different. Change, modify. You got to update the loop control variable in order to exit this loop. If we didn't have x plus equals 1, then x is always going to be less than 10 and it would run forever. Now, not every loop requires an update. If it was a for loop, then the update happens for you and you leave that line off. If it's a while true loop, which I think I've demonstrated, then while true, there's no update to do, but there better be a break statement somewhere down. Yeah, let's make sure we don't have any syntax errors. Lecture K. All right, it counted from 1 to 10. Each pass through the body is called an iteration or repetition because it's repeating it. See if I can spell repetition correctly. That looks very wrong. Repetition. All right. So this loop's going to repeat. It's going to iterate 10 times while x is incremented from 1 to 10. Don't ask me why I used single equal there and double equal there. No particular reason. This is what's called a pretest loop. The test happens up at the top. So while is a pretest loop. The test happens before the body. I guess I should have done triple quote right. There's another kind of loop called a do loop. Python doesn't have it. Not in Python. It's a post-test loop. The loop happens at the end. The test happens after the body. I'm not going to hardly talk about that because it's not in our language. But if the test asks, not my test, I'm not going to ask anything about it, right? But if MindTap asks what a post-test loop is, you're going to say it's a do loop. I don't think it does. So the loop structure, as long as a test condition continues to be true, do the process. The while statement's the loop header. The do sum process is the body. And since they're doing pseudocode, they're throwing in the end while keyword. I've only seen a few languages that actually use a keyword like that. Most of them, you either just stop indenting and it's considered done, or you use a closing curly brace. Yes, sir.
Come check this out.
Yeah, let me look.
Weird.
While you continue to be hungry, take another bite of food. Determine if you still feel hungry. I would write that something like this. Let's go back to the triple quotes. While hunger is greater than 0, how much hunger you got, right? Eat food, and then hunger minus equals 1, right? Subtract 1 from our hunger until we're no longer hungry. Silly example, but it's what the book did. I guess it's no sillier than my examples when I'm talking about if you're sick and tired, or sick or tired, you get to stay home. We all have our favorite examples. You can combine structures. Combine structures, one way to do it is just so-called stacking them. That's kind of what we've been doing, right? If something blah, blah, blah. And then maybe later on, while something blah, blah, blah. And then maybe we have another if statement. If something blah, 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 right? Just like a straight line in our flow charts with occasional fancy stuff, right? Veers off, veers off. Let me go back to my sample one. This does not show any stacked structures. I guess it does over here, maybe. Yeah, right. We have an if statement here, and then later on underneath that we have a for statement here. So if you ignore all of this, these things are stacked on each other. Then we have another kind called nested structures. Nested structures are when you have structures inside of structures, right? This guy is not stacked underneath it. It's tabbed over. So we had some kind of loop here or a statement here, and then under here we had some kind of other statement, right? And so by here we've tabbed over 2 or 3 times in order to get to that code in our typing. That's called nesting. He is nested inside of him. Just like one of those Russian nesting eggs, right? You got a little egg and a bigger egg and a bigger egg. So stacking structures. Just one after the other. If something, do something. While something, do something. And so on. I'm going to tab all that over. Highlight it all and hit my tab key. Or choose Format, Indent. This says that there's an end structure statement, like endif, end while. We've been putting those in our pseudocode, but we haven't been putting them into our code. I've been faking it by putting in comments. So here I could put pound endif, and here I could put pound end while. Examples of stacking structures. We have some sequence steps, we have a condition, and then after the condition is finally done, we're going to pretend that there was a little circle there, and then we have another condition. We know that this one's a loop because it went back. I sure do like my way of flowcharting where I actually put the word if in that loop and the word while there. Well, that's not a loop. And if in that diamond and a while that one so that our eyes immediately key in on it, but the book doesn't show that. Just like you're using that symbol for or, I'm customizing it too. So, you know, as long as we know what we mean. So, any individual task or step in a structure can be replaced by a structure. What does that mean? That means, like, what if this do something only took one statement? But later on, we decided it needs to do something more complicated. We could replace that do something with, 20 statements, 20 sequential statements. Or we could nest some loops in it, right? So you can always replace one statement with some more complicated statements. Now that sounds silly, right? It goes the other way too. If you have 100 lines of code, but a lot of it's repeated over and over and over because you copy and pasted it, you might be able to make that a function, right? So you take that code out and you put it in a function, and then you replace a whole bunch of code with just one line. Any one of these blocks could be replaced by a more complicated structure, right? If you were drawing a flow chart, you'd have to grab these things and pull them down and stuff like that. But step K could be turned into an if statement, right? And it would branch off and come back. We only have 35 slides in this, and we are now more than halfway through it because we have talked about this stuff already. Doesn't mean I don't want you to read it carefully. Just means that we've talked about it already. So I hope what I'm saying sounds like 75% repeat with 25% more specific terminology. Here's an example of a nested structure. Here we have an if, and inside it we have a while. So this would be, we have an if statement, we started tabbing. We have one layer of tabbing. And then in our loop, we have another layer of tabbing. And then the next statement underneath that would be, only one level of tabbing there, and it knows that that's the end of the while loop. How's that different than that? They've replaced step in with something even a little bit more complicated. Step in suddenly requires another if statement. But that's okay, right? We're cruising along. We hit an if statement. We hit tab. And then we hit a loop statement. And then we hit tab again. And then we have an if statement. We tab that code in there. So by this time, how many indented levels are we deep? 1, 2, 3 levels deep in our code. Tab, tab, tab. Now, that's not a perfect way of counting because this guy is also 3 levels deep, right? Because there's an else. So I'm never going to have you look at a flow chart and say, oh, by the way, which box is 3 levels deep, right? But you can kind of conceptualize it. Each time you go off to the left, you're going to be increasing your level, indentation level 1. So a structured program has the following characteristics. It's only got combinations of the 3 basic structures. Oh yeah, what about modules? See, that's why I say there are 4. Modules and module calls are a 4th form of basic structure. But no spaghetti code, right? No go-to jumping around in the code. So, good programming, and in this case, the code doesn't allow it, the program editor doesn't allow you to make anything else. Formed from creations of the 3 basic structures. Every structure has a single entry point and a single exit point. Right, here's a structure. It's only got one exit point, really. It's got something it does in the meantime, but it's only got one way out. When the loop becomes false, it's done. Zoom in on that. Here's another structure, an if statement. Right, it's only got one line going into it, and then it does some stuff, and then there's only one exit from it. Each sequential statement, each sequential structure only has one line going into it and one line leaving away from it. Which is why You're not going to get full credit if I ask you to draw a flow chart and you have box 2 lines going away from a start, or 2 lines going away from a box, or 2 lines going away. The only thing that can support multiple lines going away from it is the diamond. In which case it has 2 lines coming from it, which better eventually join back up, either in the form of a loop. Now this is a long flow chart, like that, or an if statement that hooks back up pretty soon. Structures can be stacked or connected to each other only at their entry or exit points, and any structure can be nested within another structure. Alrighty, using a priming input to structure a program. Priming is when you ask for a piece of data outside the loop that reads the rest of the data. And this says it helps keep the program structured. And it does. It's one way of doing it. I think I've shown y'all while true loops, which is another way of doing it. If I haven't, then we will hit it at a certain point. But that looks like this, and I'm pretty sure that we have done this. Priming read equals a read before the loop structure. And then there will be another read. And when I say read, it could be reading from a file, or it could be an input statement. Another read will be in the loop. So, for example, we're going to repeat something as long as the user types Y. Pretty sure I've done this. So, CH for choice equals input, parentheses, quote, do you want to play a game? Question mark, in parentheses. And then our while loop is going to say, while CH equals yes. I guess we better tell the user what to type in. How about Y or N? Right, like that. Do you want to play a game, Y or N? While CH equals, quote, Y, end quote, colon. Now, if they typed in something other than a Y, like if they typed in the whole word yes, or they type in lowercase, it's not going to go. We'll get more fancy later. Print, boom, zap, pow, end quote, in parentheses. And then print, parentheses, quote, that was fun. Exclamation point, end quote, in parentheses. Then we're going to ask them if they want to repeat the game. Do you want to play again? So CH equals input, parentheses, quote, play again, question mark. Play again, question mark. Y or N, end quote, in parentheses. And I know from experience that the output's going to look a lot prettier if we put a space there and a space there. Now we're done. Pound sign into. Why is it called a priming read? It's like the first pump. You know, you have a pump, you prime the pump. You get some water flowing. As long as you need more water, you keep pumping. When you're finally done filling up your bucket, then you stop pumping. It's not my favorite form of loop, but it's a very common one, and it's the one that all the books teach. Perfectly good way of doing it. The only thing I don't like about it is that I personally have an extreme dislike for duplicate code, and here we have the duplicate code, right? We're asking for input, and then we're turning around and we're asking for input again. And we could structure this in such a way with a different sort of structure, still be a while loop, where it only had one input. However, the logic would be a little bit more complicated elsewhere to make up for that. Let's run it, see if our game works. All right, you want to play a game? Y or in? Y. Boom, zap, pow, that was fun. Play again? Y. Play again? In. Okay. So the priming read was the one with the full sentence, right? That's kind of how we can distinguish it. Not that that's a rule, right? I did that on purpose to make sure that we could see the difference in the logic. And then once we were inside the body of the loop, we asked them for more input. We didn't even need an if statement underneath that because that's going to be handled by that while case. Once we reach the end of the loop, it jumps back up and it executes it again. Checks it again.
Invalid syntax.
Whoops. Let me come look.
Yes.
All right. So using a priming input to structure a program. The priming input, it describes. It's outside the loop. It's above the loop that reads the rest of the records. You know, it doesn't have to be a question. It could be reading from a file. And when it hits the end of the file, it finally exits the loop. Here's another thing we're supposed to do. Analyze the flowchart for structures one step at a time. All right. Like when I grade your stuff. I go in, I eyeball the structure, and I go, yeah, that looks good. You know, sequences are really easy to eyeball, right? Boom, 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 boom. But then I have a decision, and I have to kind of make sure that there's only, you know, one line leading away from it, a line coming back, and then one exit point. If it's an if statement, I make sure that we have two lines leading away from it and a place for them to hook up. Like that. You just analyze your flowchart. Watch for unstructured loops that do not follow this order. Ask a question, take an action based on the answer, ask the question again. Okay, fine. That calls my favorite programming style an unstructured loop. I guess I can live with that shame. Okay, so here's an example of a badly written loop. Input your number. Is it the end of the file? Well, it's not the end of the file. Calculate an answer, write out the answer, and then come back and repeat. Are we at the end of the file? Calculate the answer, output the answer, repeat. Are we at the, okay, there's a problem. What's the problem? We never get any further input. We have our priming read, but there better be another input down here. All right, this is even far worse. This is spaghetti code. You can draw flowcharts that you can't implement in your programming language of choice. Why is it spaghetti code? Because we have a while loop, but the line does not go back to the diamond. It goes somewhere way above. There's no way you can implement this as is. You could rejigger it, you know, put some stuff in there, add things to it, and you could turn it into valid code. But this is not valid logic. Valid logic means that if statements go apart and then hook back up, and that while loops do some stuff, and then the line comes back and hits the diamond again. Now this is actually structured correctly. Do our declarations, get our input, check to see if we're at the end of file. If we're not at the end of file, yeah, that's true, we're not at the end of file. Calculate an answer, output our answer, and then input another number. It comes back up here. Now we could implement this as code as well. I wonder if I can kind of nudge. I have trouble with this. Windows 10 does not like me to stack my stuff the way I like to staff it. Let's see if I can get that over there so that I can see my code. All right, I'm going to mirror their code exactly, including having some declarations, meaning I'm going to set those values to 0. So this is code for figure 316 in PowerPoint. So hash start, then we're going to have our declarations. Those are long variable names. I'm going to shorten them. So orig underscore num, well, that was long, equals 0. And then calc underscore, oh, you shut up. Calc underscore answer equals 0. That's still longer than I like, but we could copy and paste if we so chose. There, device is now turned off. Now we're going to get our input. Input the original number. Well, we better tell them what we want to input. Print, enter a number. Parentheses, excuse me, and quote parentheses. Now let's get our original number. I'm going to copy and paste that, being lazy. Orig underscore num, copy. Orig num equals input, parentheses input. Excuse me, input parentheses, right. Got it. And then we have to convert it into a number. Orig underscore num. Oh, that's not coming from my desktop. I guess it's every time I type something. Yeah. Stop that. Okay. Equals float parentheses orig underscore num. That's our priming read. We are here now in our flow chart. So now we're going to have an indicator. Well, how are we going to indicate that we're at the EOF? This doesn't tell us how to do it. So I'm going to go back and modify our print statement to say or 0 to quit, something like that. So enter a number, parentheses, or 0 to quit, in parentheses. Just because I don't have a way of magically determining that we're at the end of file. That's being real vague. They're not telling us how to determine that. Then our next line is going to be a while loop. How do I know it's a while loop when I'm looking at the logic? Because it's got a line going back up rather than two branches reuniting in a circle. So while orig underscore num, should it just be copying and pasting, orig underscore num is not equal to 0. Because if they type in 0, that's our ending condition. 0 is our so-called sentry value, also known as a sentinel value. It's what causes it to stop. Now we're going to calculate our answer. This says that the calculated answer is equal to the original number times 2. Being lazy, I'm going to copy that long variable name, and I'm going to paste it. Calc answer equals orig underscore num times 2. You know, if I just called it calc and orig, I'd probably be happier. Then we're going to output that. We've done the math. The math was in a square rectangle. Now we're going to do some output in a tilted rectangle. So not output, sorry. How do we do output in this language? Print. Print parentheses quote. Answer equals, end quote, comma, calc underscore answer. And if we stopped our loop there, it would just infinitely loop. So we have to have one more input statement. And the input statement, unfortunately, has to have all three of these things. We could shorten these three things into one statement with that long statement where we do, you know, orig number equals float, parentheses input, parentheses quote, right? But how about do this again? Tell you what, just copy those three statements, paste them, and tab them over. Maybe you can see now why I dislike priming reads. Anytime you're copying and pasting, it's kind of a sign of something that could be improved in my mind. But anyways, I pasted those three statements, the print and the input and the float, and then I'm tabbing them over to make sure they're still part of the while loop. Then I'm going to put, I'm just going to indicate that this is the loop. Again, this is just a comment. It's not necessary. End while. And then stop. By the way, gang, makes it hard to see. Not mine. Alrighty. I'm going to temporarily increase that to my full screen so I can test it. Then I'll bring the code back. You want to play a game? Yeah. Ooh, that was fun. Play again? Nah. Enter a number. Okay. 12. The answer is 24. Enter a number. 100. 200. Negative 1,000. Negative. Okay. All it's doing is doubling. That's fine. And then enter a number or 0 to quit. Boom. It quit. So we have properly implemented this flow chart. So our assignment is going to be to implement some code that I'm going to give you in a flow chart. I could do the reverse. I could give you the code and have you implement the flow chart. Y'all like writing code better or flow charts better? Code. Okay. I heard somebody say that.
Where it says enter a number or a 0 to quit.
Yeah.
Can we still put Q in there?
We could, but watch what happens. If I put Q there, and then when it runs, and I try it, it explodes. Now we could fix that. We could fix that. The way we would fix that is we would not do that conversion until inside the loop, and we would make sure while orig number not equal Q. I'm going to leave it alone though. I don't want to go back and fix that to make it work.
Just be confusing me anyway.
You certainly don't need to draw this flow chart. I'm going to provide it for you. This is homework. And so I'm not going to take the time to make sure you're getting it going. All right, the very first thing we're going to do is we're going to input X. But you better tell them that they can type in 0 to quit. I'm going to make an annotation to that effect if I can find the annotation symbol. Enter X or 0 to quit. Right? That's what's going on in that step. Go ahead and convert it to a float. Do anything you have to do to make that work. And come down here, and we're going to have our while loop. While X not equals 0, we're going to come over here and we're going to ask them for Y. And we're not going to tell them that they can enter 0 for while. They're committed. Once they type in a number for X, they better type in a number for Y. So input Y. Once we have y, we're going to do some prints. Print x plus y. This is real similar to our do math or something. No, but we did something like this in the past. Print x minus y. And so on. Print x star star y. And you ought to tell the user what these numbers are rather than just spitting out a series of numbers, right? Good enough. 3 things is enough. Why belabor the point? That one should have said input y. Why? Because we've already got x over here. I goofed. We asked for x over here. We asked for y the second time. Right there. All right, now we need to input x again. I'm just going to copy those 2 statements, come down here and paste them down here. And it's going to loop. And then, although I hate doing it, I'm going to kind of make him veer. Well, I'm going to draw the loop in such a way that I don't have to do that. All right. And then the last thing it's going to do is we're going to print done, and then we're going to stop. So we need a print. So output, quote, done. I guess I'm mixing up the words output and print. I'll go just with print. Print, quote, done. And then a stop, oval. Now I could clearly tidy this up by making these boxes shorter, right? And, you know, whatever. So I could fit it all on one page, easier for y'all to see. I will clean it up a little bit before I post it. But you get the idea. Okay. All right, that's our flow chart. That's what I'm going to want you to code. I'll pretty it up a little. It's real similar to what the last thing in our notes was. Very similar structure, right? It's just that we're doing a little bit more. We're getting a second piece of data. Then we're performing some print statements. However you want to organize this is fine. Just make sure you're printing the numbers added together, the numbers subtracted, and the numbers 1 to the power of the other. And then you're going to ask them for x again. And then you're at the end of the loop. You stop indenting. Make sense? All right. Yes, sir. What does it say about DOL while scanning? That can't be it, but if it is it, fine. All right, there's something else going on. Okay, okay. Nope, nope, I don't see it. Way up. Or instead of 3. Now you're going to be able to put that A sentence back in, but it should work now. All right. That one was a weird one. The slightest mistake can be hard to track down, and let me show you what I mean. Say I was up here and I accidentally had 4 quotes here. Easy mistake to make, especially when you're looking at this stuff down here, right? You don't notice you had 4 quotes there. You run it and it says EOL while scanning string literal. Now this time it's giving us an error here, right? But we go, what in the world? I don't even understand. And I didn't. I don't see his index error there. And I scroll up, I don't see his index error there. This all looks okay. There it is. We just had to keep scrolling up until something looked, you know, a little bit quirky. That. All right, let's make a Dropbox for us. We can scamper out of here.